All right. So what we have today, the assignment is the unit assessment for minerals. So it's going to go over two different sections that we've gone over. The mineral characteristics and classification section and the identifying mineral section. So I've already assigned the reading for both of these. So when you go to the assignments, you should see the assignment itself and both the readings, which will take you right here in the book. So we're going to see what the questions kind of look like and how difficult they might be. 9 questions, not too bad. Number 1 is talking about luster. Luster is going to be in, I believe, the mineral characteristics section.
Wait, is that what we're doing today?
Huh? Yeah.
Oh.
Yeah. And so it's open right now. It's assigned. And so do this ideally before you leave the classroom today, and then you won't have to worry about it over spring break. Let's see. Nah, so these are just characteristics. They talk a little bit about some of these, but not too much. I think if you go into identifying minerals, they're going to talk a little bit more in detail about these different things. And so right at the top of the identifying minerals section, you see a little subsection about luster. And so the answer for your luster question will definitely be in there. What is not a type of luster? Just compare your 4 answers to the list of lusters right here, and you should be able to find it pretty easily. Number 2, which of the following is a way that scientists classify minerals? So they got 4 different answers here. And mineral characteristics or classification is probably going to be where you find these. And they kind of give you your definitions of minerals, characteristics, classifying minerals. And so down here, they're going to talk about classifying minerals. You're going to have 2 major groups. You're going to have your silicates and your non-silicates. Silicates are going to be based on the shape that the molecules form when they stick together. And then your non-silicates are going to be based on their mineral composition. So let's see what they have. In the following ways, scientists classify minerals by a geological process that created them, by the location in the Earth's crust where they were formed, by the shapes and sizes of their external surfaces, by the arrangement of their atoms, ions, and molecules. So you can look through these. I think the arrangement of their atoms, ions, or molecules is the reason they have a specific shape. So D over C. But just take a look and see if you think that one's better than one. I'm kind of leaning towards D here and the arrangements of their atoms, ions, and molecules. But there are several different ways you can kind of classify minerals depending on which one you have. What property do all minerals have in common? That's going to be right at the top of the page of the mineral characteristics section. And so it's going to be one of these 4. These are the 4 things that all minerals have to have in common. These are what makes a mineral. So you should be able to find one of these answers here in one of these 4 little bullet points there. Why is calcite classified as a non-silicate? Well, silicates have silicon and oxygen. Calcite doesn't have silicon. It has calcium and oxygen. And so without that silicon-oxygen molecule, it's not going to be considered a silicate. So silicates have to have that silicon-oxygen tetrahedron, and if you don't have that, you're not a silicate. What is a class of silicate minerals? If you come back to, I think the classifying page, and then come down to classifications, they talk about silicates, and they list a couple of their different classes right here, and these paragraphs right underneath this. Let's see what options they give you here. Cyclo, tetra, silicate dioxides, nanosilicates. Which is a correct class? Do they have that? Maybe it's an identifying. Let me see. I don't know where they go in and talk specifically about the silicates.
I couldn't find it, but so I got that one wrong.
You couldn't find it? I imagine you spent a lot of time. When did you do the assignment?
When did you open your Chromebook?
I know. It's like I couldn't find that one.
I
I'm not trusting that you spent a lot of time working on it.
Hey, I only missed one question.
Well, that's good. That's good. And that must have been the one that you missed.
Yeah.
Um,
What I pick? I don't think it's
silicate. So on this one, I'm guessing it's going to be between A and B. I'm pretty sure it's going to be A. What did you guess on that?
I picked B, but it's.
Yeah, all the silicates have the tetrahedra, so I don't think that would be a way that you classify them. How you do it? You have sheet silicates, you have ring silicates, and chain silicates, and so I think the ring silicates could be called cyclosilicates because a cycle is like in a ring or circle, and so I think cyclosilicates is going to be the correct one. To be honest, they might have only gone through that in the exploration, which was not super great, and so we didn't really do it. But yeah, they definitely don't have a list of silicates here. And so I'm pretty sure it's going to be the cyclosilicate.
So what you're saying is you can't find it either.
I mean, if I had a keyboard right here, I could just Google it, and that would tell me what it is. Types of silicates would get me there. Why is quartz classified as a silicate material? Again, all your silicates have to have that silicon oxygen tetrahedron. So one silicon, 4 oxygens. If it can build that, that makes it a silicate material. And so if quartz is classified as a silicate, that's the reason why. It has the silicon oxygen tetrahedron. Which mineral is a non-silicate? So they're going to have, I would go back to this list. Go to the mineral characteristics and classification page. Scroll down until you see this little chart. And on the right side of the chart, they have examples written here. And so you have 3 examples of silicates and a bunch of examples of non-silicates. And so match that up to what they have here. They got 4 answers for you. One of those should be on the non-silicate page because that's what they want to know. Which mineral is a non-silicate? So see which one of those is down here in your non-silicates. It should be good. Number 8. Last 2. Which statement explains how strip mining damages the surrounding environment? So strip mining, I think, is going to be at the bottom of identifying minerals, or is it characteristics? No, it's going to be in the bottom of the other one. The mineral characteristics and classification page. Scroll all the way down to the bottom. And what they talk about in this last little section is mining. Specifically, strip mining is down here in this last paragraph. So read a little bit about strip mining, and that should lead you to the correct answer in question number 8. And then number 9, are bones considered minerals? Why or why not? Again, go back to the mineral characteristics page, and this time right up at the top. Number 3, which one is it? Number 2. Minerals are inorganic or non-living. Minerals formed by chemical and geologic processes, not biological processes. And so I think that's going to be your definition that you're looking for there. Bones come from inside living things. They grow with us. They're definitely a biological piece of material. And so minerals cannot be biological. So I would highly doubt that bones can. So that's your assignment. If you have any questions, let me know. If you need any help, let me know. But that's what we're working through today. And then once you're done, hit submit. And for this class, you're technically on spring break. Not really. You can't leave or nothing. But all right, light coming back on. Well, you know the deal. You know the deal. We got bells. We got schedules and all that.